Hello everyone, welcome back to my channel. So dear friends, today I have taken the important problem from the root locus, especially it was asked in the February-March 2022 VTU examination. Okay, let us try to solve it. It is little bit tricky. So you already know the steps of the root locus, as I have already uploaded the videos on root locus. You can go through. I have provided the link in the description box so that you can understand the basic lecture of the root locus. Okay, let us understand this problem now. G of s h of s is equal to k of s plus 1 s into s plus 2 s square plus 2 s plus 5. It is the transfer function given. Sketch the rough nature of root locus. So we have to draw the root locus for this problem. Okay, so step first, you already know you have to calculate the number of zeros and number of poles. The terms in the numerator are called the zeros, the terms in the denominator are called the poles. Okay, so in this particular function, 1 0 is present. Okay, so number of 0 is 1, that is s plus 1. Whatever the terms are in the s format, so that are the zeros in the numerator, and the denominator, these are called the poles. This is called as pole at origin, simple 0, complex 0. Okay, so number of zeros is equal to 1, number of poles is equal to 4. Why 4? This is 1. Okay, pole at origin, simple pole. In complex pole you have to calculate it in the calci over here. Okay, so let me show you. This is the alpha a equation you have to write. Sorry, this is menu alpha a. So polynomial you have to choose. Okay, so second one, what is the degree? That is second. Okay, second degree, so 2 you have to take. What is the equation? So what is the coefficient of s square? That is 1 is equal to 2 is equal to 5 is equal to you will get -1 plus 2i and -1 minus 2i. These are the two poles over here. Okay, so actually these are the two roots, so roots are nothing but poles. So these are two poles and these two poles. Okay, by calculating it in the calci, you will get two roots over here that also constitute the pole over here. So that is why I have written number of poles is equal to 4. So what is the value of poles? You have to substitute this is equal to 0. S is equal to 0, that is one pole. S plus 2 is equal to 0, so s is equal to -2. When you just shift this 2 into the right hand side, so you will get -2 value, and these two values are already calculated in the calculator. -1 plus 2i, -1 minus 2i. So these are the number of zeros and number of poles. Step 2 is number of branches. If the number of poles are greater than number of zeros, then branches are always equal to the number of poles. Okay, so n is equal to 4 in this problem. Number of branches terminating at infinity is equal to the formula p minus z. So poles are already given 4 minus 1 is equal to 3. I'm just making fast this video so that it will get too long. So dear friends, I don't want that, as already I have explained it in the previous videos. So I'm just making it fast as much as possible. So number of branches terminating at infinity is equal to this much, 3. So starting point of branches, you already know, I have given the statement that branches always start from 0, or branches always start from poles and terminate at infinity or at 0. But in this particular problem, number of zeros is 1, so definitely one branch will terminate at 0. So see here, end point of the branches is -1. Why -1? It is the 0 value. Number of 0 is equal to 1. When you just put s plus 1 is equal to 0, so you will get s is equal to -1. So that is the 0 value, like -1 here. Okay, so starting point of branches from always from poles. So what are the pole values? 0, -2, -1 plus 2i, like that. It will always start from these 4 values and terminate at either 0 or infinity. So one value definitely will terminate at -1, and other 3 will terminate at infinity. Okay, so step 3 is segment belonging to root locus. So you have to take segments. First of all, draw the real and imaginary axes. This is your real axis and this is your imaginary axis. Fine. So what are the pole values? 0. So mark 0 as cross. Okay, so poles are always denoted by these cross values. So cross you will take, and -2 is also a pole, so just draw it. Okay, on the real axis, and 1 0 is present at -1 value, so I am putting it as 0 value at -1. Now you have to take the segment belonging to root locus. So first of all, I will take 0 0 and -1. You have to draw one line and it should be pointed towards right half of the s plane. This is called as s plane over here. Okay, so on the right half of s plane, what are the number of zeros and poles? so pole is only one here. You see, pole is only one, so that is why I have written here number of poles plus number of zeros is equal to 1. One pole is here. Okay, so on the right hand side, is there any zero? No zero present. Okay, so 1 plus 0 is 1. Therefore, if I am getting odd term, that is root locus exists between these two segments, that is minus 1 comma 0. Then I will take minus 2 comma minus 1, minus 2 comma minus 1, and you have to draw the segment pointing towards right half of the S plan. Okay, so on the right hand side, how many zeros and poles? So one pole is here and one zero is here. Okay, so I am writing here number of poles plus number of zeros, 1 plus 1, that is 2. If you are getting even term, then no root locus exists. Okay, I hope this is clear. So next point is between minus infinity and minus 2, you have to take this one, minus infinity to minus 2 segment. So when you draw this segment on the right hand side, so you can look on the right hand side how many poles and how many zeros. So one pole, two pole and one zero. So two poles and one zero. So that is why I have written here number of poles plus number of zeros is equal to 2 plus 1 is equal to 3. Therefore it is the term is odd. A root locus exists in this problem over here. Next is step 4, angle of asymptotus. Wherever these branches meet what should be the angle at which these branches start, that are called the angle of asymptotus. So theta, the formula is 2q plus 1 into 180 divided by p minus z, where this q value starts from 0 1 2 and ends at p minus z minus 1, that is pole value and zero value. Pole is 4 in this problem, minus 1 is zeros are 1, so 4 minus 1 minus 1, that is 2. So up to the 2 q value will exist. So q is equal to 0 1 2. Hope it is understood. So just put these values 0 1 2 in this equation. First put 0, then put 1, then put 2, like that. You will get theta 1 is equal to 60 degree, theta 2 is equal to 180 degree, theta 3 is equal to 300 degree. These are the angle of asymptotus. Next is centroid value you have to calculate. So sigma is equal to a summation of real part of poles and real part of zeros upon pole minus 0. So sigma, real part of poles you already know here, that is 0 minus 2 and minus 1. This is the imaginary part. You don't have to take this and minus 1 from this particular part. Okay, so 0 minus 2 minus 1 minus 1 and minus 0 value is already minus 1, so you will take it. So minus 4 plus 1, you will get sigma centroid value is as minus 1. So up to this is the centroid value. Then step 6 is breakaway point. You know already in the root locus there always exists a breakaway point. So for that you have to take characteristic equation. So 1 plus g of s h of s is always equal to 0. So 1 plus, what is the g of s h of s? It is the given function k into s plus 1 s into s plus 2 s square plus 2s plus 5 is equal to 0. So you will just multiply it. So 1 plus k into s plus 1 is same, divided by s into s is s square plus 2 into s is 2s into s square plus 2s plus 5 is equal to 0. Okay, so this is the breakaway point, about breakaway point. So see here, then s square plus 2s, I will multiply it with this one. So s square plus 2s into s square plus 2s plus 5, I will multiply it with 1 over here, plus k into s plus 1, k into s plus 1, and this denominator will get shifted to the right hand side. It will become 0. Okay, so when you just calculate this, you will get s into s square into s square is s raised power 4 plus 2s cube. See here, 2 into s square, 2s into s square is 2s cube, plus s square into 5 is 5s square, plus 2 into 2s into s square, that is 2s cube, plus 2s into 2s, that is 4s square, plus 2 into 5 is 10s, plus k into s plus 1 is equal to 0. Like that you will calculate it, I know. So s raised power 4, so 2s cube plus 2s cube 4s cube, you will get like this equation. Okay, then you have to separate the k value. So k is here, you just transfer these terms on right hand side. So minus s raised power 4 minus 4s cube minus 9s square and minus 10s divided by this s plus 1. Now it is in the u by v format. You have to differentiate k with respect to s term. So dk by ds is equal to 0 you have to take, and now differentiating this term, it is u by v rule. So v as it is, s plus 1 as it is, differentiation of this term, that is 4s cube minus 4s cube minus 4 3s are 12s square plus 9 2s are 18, so minus 18s and minus 10 into s, differentiation of 10s is 10. Okay, then this term as it is minus this term as it is into differentiation of this v. So differentiation of s is 1, so multiplied by 1 divided by s plus 1 whole square. Why? In uv rule, u by v rule, it is v as it is differentiation of u, then u as it is differentiation of v divided by v square, s plus 1 whole square. When you just multiply it, see here, this is your 4s cube into s, that is 4s raised power 4, then s into this 12s square, it will become minus 12s cube, then 18s into s, 18s square. Fine. So like that you will multiply it, so you will get this term. Then see here, 1 into 4s cube, that is minus 4s cube, 1 into this 12s to minus 12s square, 1 into 18 minus 18s, minus 10 into 1 is 10, then this term minus minus will become positive, 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 all the terms will be positive. So you just cancel out 10s, 10s cancels, 4s cube minus 4s cube cancel, you will get like this format, minus 3s raised power 4 minus 12s cube minus 21s square minus 18s minus 10 is equal to 0. Then you have to calculate the roots in the calci part. I hope you will calculate it, dear friends. You are too matured about this particular finding of the roots of the equation. So you will take alpha a polynomial, it is of this time 4 degree, so you will take 4. So now put the values, that is minus 3 is equal to minus 12 is equal to minus 21 is equal to minus 18. Okay, minus 18 is equal to minus 10 is equal to you will get, see here, 0 minus 0.42. sorry, I have taken wrong values over here, so sorry, I was taking the wrong value over here. So I am getting here, by putting in the calci, you will get values like 0.36 is the first value, and another one is the minus 2.36, and rest one is the minus 1 plus 1.69, so it is 69 over here, and next one is minus 1 minus 1.69. okay, I hope this is clear. It is just the calculation part, you will do it later on. So first understand the steps. So now if you have to check these values are valid or invalid, okay, so complex, in order to find the complex values, in order to check the validity of the complex poles, you have to use the angle condition to check the validity of the complex roots. okay, so take the angle condition, it is always equal to g of s h of s, and this term already I have explained in the very beginning lecture, first lecture itself. So angle condition is also always equal to angle of g of s h of s is equal to plus minus 2 q plus 1 into 180, that is in short, it should be the odd multiple of 180, and the angle should be the odd multiples of 180. okay, so let's take angle of k into given function, k into s plus 1 upon s into s plus 2 s square plus 2s plus 5 at given s, that is complex value is minus 1 plus 1.69 I, you have to take s value. okay, so for this value you have to check the angle condition. So I will show you again in the calci, I have shown you this prior before this particular lecture, so but I will show you in this video also, if somebody is watching this video new over here, so that will become crystal clear. okay, so let's take the first that is your complex 2. so now angle minus 1 plus 1.4 I plus 1, that is 1 and minus 1 will get cancelled, you have only left with 1.4 I and 0 real number. okay, so you will take 0 plus 1.4 ng button I, you have to make it. okay, then options, then you will choose 1 over here, you will get 90 degree. okay, so in the next page I will show you the angle. Likewise you have to calculate these values, okay, over there. So only one value I will calculate here, it will be the video will get too long, dear friends, so I don't want that should happen over here. I hope you will clear these angles. So first one I have calculated, that is 90 degree over here, that is I have written here 90 degree, then accordingly you will get the angle is 126 degree 54 minus 90 90. When you shift these terms into the numerator, it will become accordingly, this will become minus, and this the positives will become negative, and negative will become positive in the numerator. So 90 minus 126 minus 54, this is minus 90, it will become positive 90, this is positive 90, it will become minus 90, 90 90 get cancelled, you will get total value as minus 90. So minus 90 is definitely not the odd multiple of 180 degree, sorry, this is 180 here, 180 degree. okay, so these roots are invalid. Now for the validity check, you are supposed to check the validity of the roots. okay, now step 7 is intersection with the imaginary axis. So this is the very important step, just because the branches we should look upon here, that where they are meeting at the imaginary axis, as there are real axis and imaginary axis. So we have to mark that particular point on imaginary axis so that we can recognize the points where it is intersecting. So from Routh's H criteria, you have to take the characteristic equation. So already we got characteristic equation here, s raised power 4 4s cube. Okay, so you have to put it here. So for s raised power 4 plus 4s cube plus 9s square, you just multiply this k into s into k into 1, you will get ks, sorry, 10s plus ks. Okay, so as I am not wrong over here, okay fine. So this is k into s plus k into 1, you will get 10s plus ks plus k. So taking common s over here, you will get 10 plus k into s raised power 0. Why I'm writing s raised power 0? Anything raised power 0 is equal to 1, so it will not affect the equation. So this is s raised power 1. Now you have to take in the decreasing order, first higher order, then decreasing. S raised power 4, s raised power 3, s square, s1, s raised power 0. What is the coefficient of s4? That is 1. What is the coefficient of s square? You have, if you have taken even term first, then accordingly you have to go for evens. So s square is 9, then s raised power 0 is k. Then if you have take odd term here, s cube, so what is the coefficient? 4. What is the s raised power 1 coefficient? 10 plus k is equal to 0. Then calculations you already know, this into this minus this into this term divided by this term. Already I have discussed it. So calculations you can see here, 9 into 4 minus 10 plus k into 1 divided by 4, you will get accordingly this value, 26 minus k. This is the calculation part, you will do it. And also I will share this particular note copy into the description over there, so that you can understand this concept very easily over there. This is the calculation part, I have written on it, it on the right hand side. Okay, so then you have to take this value 260 minus k square, whatever the s raised power 1 term is there, you have to equate it to the 0 part. Okay, you will get the k value. So k square is equal to 260, k is equal to under root of 260, k is equal to 16.12 you are getting in this case over here. Okay, next part is the auxiliary equation. If you put this 16.12 in this equation, you will get 0 0. Okay, so this becomes 0, this becomes 0 0 row. The above equation is the auxiliary equation above the zeros. Okay, whenever you are getting the row as 0, okay, the 0th row above the equation is called as auxiliary equation. Okay, I have taken it over here. That is auxiliary equation is 26 minus k divided by 4. See here, 26 minus k upon 4, and s square you have to take. Okay, s square plus this is k is equal to 0. Then 26 minus k upon 4 is s square. So you have to put down the value of k. Already you are getting it in the above step, that is 16.12. So 26 minus 16.12 upon 4 into s square is equal to minus 16.12, just putting k value. So s square is equal to this term, s square is equal to this, s is equal to under root of this term 6.52, you will get plus minus 2.55. so you are getting this intersection point on the imaginary axis. So plus minus you will get definitely, just because imaginary part consists of plus I and minus I, so you have to take accordingly. Okay, now this step 8 is angle of departure. Why I am calculating angle of departure over here? Just because I am getting complex poles in the question. See here, so see here, poles are minus 1 plus 2i, minus 1 minus 2i. So these are the complex roots. Whenever you are getting complex roots or complex poles, so then you have to go for the angle of departure. First of all, draw the real axis and imaginary axis, fine, and mark the poles and zeros. So 0 is your pole, minus 2 is also your pole, and also these complex poles, that is minus 1 plus 2i, minus 1 minus 2i. Okay, these are the poles, just cross it, so that it will depict that these are poles. And also 1 0 is present at minus 1 value. Okay, then you have to join these poles with the complex poles. Whatever the poles are there, you have to join these poles with respect to these complex poles. Okay, but always prefer which the poles which are in the second quadrant, you have to join all the poles to that particular pole. Okay, so this pole I am joining here, this pole I am joining here, and this pole I am joining here. Okay, so now you have to calculate the values for the poles. So this is your 5p1, that is pole 1. So 5p1 is equal to, see here, this is total 180 minus this angle, you will get 180 minus this angle. How you calculate? Tan inverse of opposite side by adjacent. so this is your opposite side is -2, so tan of the length is 2, you don't have to take minus value, so tan inverse of 2 upon what is this length, that is -1, so 2 upon 1, 180 minus this you will get in the calci part 116 degree. So next is 5p2, this angle perpendicular by base, so perpendicular is 2 over here and base is -1 length, okay, sorry 1, so 5p2 is equal to 63.43 degree. Then pi p3, so this is the pi p3 with respect to this horizontal axis, it is always 90 degree now, so p3 is equal to 90 degree, fine. So then 1 0 is present here, so angle is 90, so summation of phi z I can write 90 degree. When I do summation of poles, so you will get 116 plus 63 plus 90 degree, you will get 270 degree, okay. So for the angle of departure, first of all you have to calculate phi, simple phi, which is equal to the summation of phi poles and minus summation of phi of zeros. So phi of poles is 270 minus phi z is 90, so 270 minus 90 is equal to 180 degree, okay. So angle of departure formula is phi d is equal to 180 minus phi, 180 minus phi you have already calculated here, so 180 degree is equal to 0 degree. So angle of departure is equal to 0 in this degree, in this particular problem, angle of departure is 0 in this problem over here, okay. So then in order to plot the root locus, okay, so you just draw the image, I will show you also in the video, I will draw it new over here so that you will get clear image. So this is the real axis, this is your imaginary axis, fine, positive I and negative I. You will mark first the poles, 0 -1, this is your 0 and this is your pole again -2, this is your 1 2, roughly diagram I am drawing here, okay. So this is -1 -2, so what is the another pole, that is this one, okay, fine, these are the another two poles, you have to mark it, okay. Then you have to look upon the centroid value. What is the centroid value, sorry it is here I think, sigma is equal to -1. You have to draw the angle of asymptotes from this only, sigma. So theta are 60, 180, 300, okay. So at -1 you have to draw these angles 60. Suppose I am taking here -1 is centroid, -60 is somewhere here, suppose I am drawing roughly, you can draw it with the help of what we call as D protector over here. So and next angle is 180 is like this, okay, then 300 is like this, okay. So this is your first thing that you should mark the angle of asymptotes. Then you have to go for the root locus. So first of all, what is the intersection point and breakaway point, already calculated. So breakaway point where I am getting, yes, breakaway point, yes, so breakaway point is here 0.36 and -2.36. first of all you should check the validity of these, are they valid or not. So how you can check the validity of these, it is in this particular step itself. So 0.36 is between 0 and -1. So first see -1 and 0 root locus exists, so there will be the breakaway point between 0 and -1. So 0.36 is valid in this case, okay. So -2.36, is it valid? So see here -2 and -1, so sorry it will not come in this particular picture. Then between this -infinity and -2, see here -2 and -infinity, there will be 2.36 value, that is also a breakaway point, it will be valid, okay. So I can take 0.36 in this case, minimum one breakaway point I can take in the diagram, that is 0.36 will be somewhere here, 0.36. so you have to start the root locus from this point itself, the breakaway point, and then what is the cross sectional point or intersection point, you will say easily, that is 2.55, it will be somewhere here, 2.5 will be somewhere here and 2.5 will be somewhere here, okay. Then you have to draw accordingly the root locus from this 0.36 point. Draw a smooth curve, you can draw it like this, smooth curve, then accordingly draw the parallel line, okay. Then from this point you have to draw the again one root locus and draw the parallel line, okay. Angle of departure is 0, so no need to go for the angle of departure, you will get like this diagram in this particular case over here. I hope this is clear. If it is not clear, dear friends, so you can comment down where you have a confusion so that I can clear it. And also I will share this note in the description or comment box over there. So thanks for watching my video. If you want some other questions, you can comment down so that I can make the videos accordingly.